All right, let's talk about BigQuery ML. You know, if you're totally comfortable with SQL, but the whole world of machine learning just feels like a completely different, complicated language, well, this is for you. We're going to break it all down, one simple step at a time. So let's start with a little thought experiment. What if building a really powerful machine learning model was less about writing complicated code and, I don't know, more like baking? Following a recipe, using tools you already have, and creating something pretty amazing from scratch. And that, right there, is the entire idea behind BigQuery ML. It's basically a complete toolbox that lives right inside Google BigQuery. It lets you build and use machine learning models, but the recipe language? Well, it's the one you already know and probably use every day, SQL.
Okay, first up, ML in your comfort zone. The first big idea to really get is that all of this happens right where you already work. You're not going to be learning Python. You're not setting up complex new environments. It's really just like adding some powerful new ingredients to the data warehouse you're already an expert in.
Yeah, think about it like this. BigQuery ML isn't some separate app you have to go out and learn from scratch. It's a set of features, a special toolbox that's already built directly into the BigQuery you're using. And that, of course, makes getting started incredibly fast.
So, with that in mind, let's get to the really fun part, crafting the perfect recipe. This is where we actually build our model and start tweaking it to get the absolute best results possible.
And the basic recipe is surprisingly simple. It all kicks off with a create model statement. This is basically you telling BigQuery, hey, I want to predict which customers are going to churn, or I need to forecast sales for next quarter. From there, BigQuery ML does a lot of the initial data prep for you automatically, and then you get to tune it, and that's where the real magic happens.
Now, this brings us to a word that, I know, sounds a little intimidating, hyperparameters. But let's just forget the fancy term for a second. Think of them as the settings on your recipe that you decide before you even start baking. How hot is the oven? How long do we bake for? 2 cups of sugar or 3? Those are your hyperparameters. You set them up front to guide how the model learns.
So how do you adjust those settings to find the best possible recipe? Well, BigQuery ML gives you 2 main ways to do this automatically. For stuff that's on a scale, like numbers, you use hparam range. That's like telling it, hey, try a bake time anywhere between 10 and 15 minutes and see what works. And for specific choices, you use hparam candidates, which is like saying, okay, let's try one batch with butter and another one with shortening and see which one tastes better. So you've baked your model, you've followed the recipe, but now comes what is probably the most important part of the whole process, the critical taste test. You've got to evaluate it to see if it's actually any good. I mean, you followed the recipe, the model is built, it looks like a perfect cookie. But what does it actually taste like? How is it going to perform out in the real world on data that it's never, ever seen before? You just can't assume that the first bake is going to be the best one. And here's exactly why that taste test is so critical. It's to avoid a classic problem called overfitting. See, if you test your model on the same data it learned from, it's like tasting the exact same cookie you just ate. Of course it's familiar, the model's just going to get a perfect score because it memorized the answers. The real test is using evaluation data the model has never seen before. That's like tasting a new cookie from the same batch. That's how you know if the recipe itself is truly good. So how do we actually do this taste test in SQL? It's simple. You use the ml.evaluate function. This one command runs your model against that unseen evaluation data and gives you back a full report card, measuring things like accuracy, precision, and error rates. And one of the most useful parts of that report card is the confusion matrix, which you get with a function called ml.confusionMatrix. Let's say you're trying to predict spam emails. This simple table shows you exactly where your model is being smart and where it's getting confused. It'll show you how many actual spam emails it correctly caught, that's a true positive, and how many it missed, which is a false negative. It's just an incredibly clear way to see how your model is performing. All right, our model has passed the taste test. It's good to go. So now it's time to actually put it to work. And this brings us to serving up predictions and, just as importantly, understanding the why behind them. Getting your prediction?
sometimes you'll hear it called inference, is as simple as you'd hope. You just take a table of new data, say a list of new customers or new houses on the market, and you feed it to the ml.predict function. BigQuery will just hand you back that same table, but with a brand new column that has the prediction for every single row. It's really that easy.
So you get a prediction. This customer is likely to churn. That loan application is probably a no-go. This house is worth $500,000. Awesome! But why? Why did the model actually arrive at that specific conclusion? This is often the most important question you can ask.
And the answer to that why is something called explainable AI, or XAI for short. Just think of it as the tool that gives you the ingredients list for your prediction. It looks at a single outcome and tells you exactly which features, which ingredients pushed the prediction one way or the other. And there are kind of two flavors of this why. First, there's local explainability. That's like asking why this one specific cookie tasted so amazing. It gives you the reasons behind one single prediction. Then there's global explainability, which is more like asking what makes all our cookies good in general. It tells you which features are most important for your model's performance across the board.
Okay, so we've made a great recipe. We understand why it works, but you don't want to be in the kitchen baking one cookie at a time, right? The final step is to scale up and run an automated bakery, putting this entire workflow on autopilot. And this is done using something called an ML pipeline. It's really just an automated step-by-step workflow that connects all the pieces we just talked about. It'll automatically prep the data, train the model, run the evaluation, and then deploy it so it can start making predictions. It's your completely hands-off assembly line. And BigQuery gives you a few different tools for building these pipelines. For the really complex jobs, you've got Vertex AI pipelines. That's your super sophisticated, customizable assembly line. For simpler things, you can just use Google SQL queries, kind of like a simple recipe card. And for more complex but still SQL-based workflows, there's Dataform, which acts like a shareable, version-controlled recipe book. And what pulls this all together is the Vertex AI model registry. When you register your BigQuery ML models here, you get a single, central command center for all of your recipes. You can track different versions, compare how they perform, and manage the whole lifecycle from one spot. It's really the key to going from being a hobby baker to running a professional operation. So, what does this all mean? It means BigQuery ML brings the massive power of machine learning into the familiar, comfortable world of SQL. The kitchen is open, the ingredients are already sitting there in your data warehouse, and the recipes are written in a language you already speak. So the only real question left is, what are you going to bake first?